Hello students, today we are going to start a new topic which is called ionic and covalent bonding. Together they are called chemical bonding. You see that atoms, atoms you know very well, these are the smallest particle of an element, and you know that atoms, they are not able to exist independently. Like for example, oxygen atom. It is not stable, it cannot exist independently. So what happens is oxygen combines with another oxygen atom, to give you O2, oxygen molecule. Again, another example we can take, sodium atom. Not stable, it can combine with one chlorine atom to give you NaCl. Stable NaCl molecule. Yes, so you could see that atoms, they are not stable, so they combine with other atoms to give you molecules. Atoms can combine with the atoms of the same element or atoms of another element to give you molecules. Now the question arises, why do atoms combine? Why do atoms combine? Now atoms combine to gain stability, to become very stable. So before we talk more on the stability, I'd like to tell you there is a group of elements called noble gases. You must have heard about noble gases. In the previous chapter, you saw periodic table. Yes, periodic table. So have a look here. Group 18 elements. Yes, to the extreme right hand side of the periodic table, there are group 18 elements which are very stable. These elements are helium, neon, argon, krypton, xenon, and radon. They are very stable and they do not like to react with other elements. Yes, these are called your noble gases, also called your inert gases. Now if you look at the electronic configuration of these noble gases, you see that these will have 8 electrons in the outermost orbit or the outermost shell, that is called your valence shell. If you look at neon, its atomic number is 10 and the configuration is 2, 8. Argon 18 and the configuration is 2, 8, 8. Krypton same thing, at the end is 8. So the reason for their stability is because of the very stable configuration like this. Stable configuration means the octet configuration. Octet means 8 electrons in the outermost shell. In the valence shell. And there is one exception, that is helium, which will have duplet, that is 2. This is also very stable. So they could see that the noble gases are very stable. They do not like to react with other elements. The reason is because of the stable configuration, which is called your octet configuration. So we could see that atoms of other elements, other than noble gases, they do not have octet configuration, so they are unstable. So what do? They combine with other atoms to gain the very stable configuration of the inert gases. So we got the answer. Why do atoms combine? Atoms combine to gain stability. And how do they gain stability? How do they attain stability? By having the stable electronic configuration, that is the octet configuration of inert gases. Then have a look here. Oxygen, it is forming oxygen molecule. Now I'll draw out here, this is 2 oxygen atom forming an oxygen molecule. When they form a molecule, there will be a force of attraction between these atoms. Force of attraction. They'll attract one another. Yes, the atoms. There will be a force of attraction between the atoms in the molecule. Now this attraction is called your chemical bond. So what is chemical bond? Chemical bond is nothing but just a force of attraction between the atoms of a molecule. It can be of elements like this, or it can be of compounds. Na and Cl, there will also be a force of attraction. That force of attraction is called chemical bond. And when atoms combine like this, to form molecules, their potential energy also decreases. Okay, the energy decreases because there will be a force of attraction. So because the potential energy decreases, they will be stable. Okay, less energy, a compound or molecule will be more stable. More energy, less stable. Okay, so in short, we can say that atoms combine chemically to gain stability by attaining the very stable configuration and by also having the least possible energy. Okay, by having lesser potential energy. Okay, less energy means higher stability. Like for example, if you have a lot of energy, no, you are not stable. Okay, you constantly want to go out, run, do something, okay, dance and all. Okay, you're not stable. If you have less energy, you'll just lie down. Okay, yes, you said no, you'll be stable. Same thing. Yes, less energy, more stable. Then another thing, now you saw that atoms combine to have a stable configuration. Okay, like for example, I'll give you one example. Na281. You know that this is the configuration of sodium. Okay, chlorine, you know that configuration is 287. This is the configuration. Now sodium would like to have a very stable configuration of octet. How can it achieve octet? By giving this one electron, by removing this one electron. Yes, by the loss. It can have octet by adding, if you add one more electron, it will be 288 by the gain. Or there is another way, by sharing. Okay, we'll see in oxygen. Okay, so atoms can lose or gain or share electrons to have stable electronic configuration. Okay, so chemical bonding, there are two types. Okay, for a syllabus, it's you are given just two, but there is one more also called coordinate bond. Okay, so chemical bond, two types: ionic bond, also called the electrovalent bond, and the other one is covalent bond. So in the ionic bond, there will be loss or gain of electrons, and in covalent bond, there will be sharing of electrons. Okay, to have what? To have a very stable configuration of octet. Now we'll do ionic bonding. Okay, but before that, we need to revise a few things. Okay, this you already know, but still you need to have it. You need to have it clear in your mind. Ions. You know the term ions? Ions are like this. Yes, Na plus, Fe2 plus, Cl minus, and so on. Ions, what are they? They are charged atoms having some charge. Okay, atoms having some charge are called ions. You know, charge can be positive or negative. Therefore, ions can be positive ions or negative ions. Positive ions are called cations. Negative ions are called anions. Okay, cations here, they are formed by the loss of electron from a neutral atom. When a neutral atom loses one electron, they will form cation. Have a look. Na, if it loses one electron, it will get converted into Na plus. Yes. Mg, magnesium, if it loses 2 electrons, it will get converted into Mg2 plus. The charge is 2 plus because 2 electrons are, it loses 2 electrons, okay, are lost from here. Anions are formed by the gain of electrons by a neutral atom. Okay, negatively charged ions are formed by the gaining, okay, by the acceptance of electrons. Like chlorine atom, Cl is there. If one electron you give to chlorine atom, it will give you Cl minus, anion. Oxygen atom, if you give 2 electrons to oxygen atom, you'll get O2 minus. Yes, so that is cations and anions. Now we need to know one term here, electron dot structure. Okay, you need to know how to draw the electron dot structure. It's very simple. Electron dot structure, how do you make? Like for example, if you want to draw for sodium. Okay, sodium, you know very well, sodium electronic configuration is 281. No, atomic number is 11, 281. To draw the electron configuration of sodium, what you do, you write its symbol. Yes, Na. And outside here, you may draw dots. Okay, this dot or dots represent the valence electrons. You know valence electrons? Valence electrons. Okay, you did in periodic table, yes or no? Valence electrons means the outermost electron. How many outermost electrons are there? Just one. Okay, so one dot. Yes, this is how you draw the electron dot structure. If you want for magnesium, Mg electronic configuration is 282. How do you draw its electronic configuration? Electron dot structure. Mg. How many valence electrons? 2. Dot, 2 dots. Okay. Chlorine, it is 277. How do you draw? 7, you need to know. 1, 2, 3, 4, 5, 6, 7. Okay. Now instead of dots, you can also put crosses. Okay, doesn't matter. Crosses also represents the valence electron. Like oxygen 6, 1, 2, 3, 4, 5, 6. Okay, so this is how you draw the electron dot structure. Its symbol and the valence electrons represented by dots or crosses. The first type of bonding we are going to learn about is ionic bonding. Okay, or ionic bond. Now, ionic bond is formed by the transfer of electron. Okay, complete transfer of electron from one atom of an element to another atom of another element. So ionic bond is formed by the transfer of electron from one atom to another atom. And usually the transfer takes place from metals to non-metals. Metals, you know, they can easily lose electrons. And non-metals have tendency to accept electrons. Okay, so last time you saw the periodic table. Okay, and if you look at the periodic table out here, okay, these are your metals. And the purple one out here, these are your non-metals. Okay, metals have tendency to lose electrons. Non-metal have tendency to accept electron. Okay, so ionic bond forms between highly electropositive metals. Highly electropositive metals means high tendency to lose electrons. These are the ones. Okay, highly electropositive elements. Sodium, magnesium, calcium, potassium. Highly electronegative non-metals would be oxygen, fluorine, sulfur, bromine, and so on. Okay, so it is formed by the transfer of electrons from metals to non-metals. Example we see is in the formation of NaCl, sodium chloride. Now have a look. Sodium chloride, it's made up from sodium and chlorine. Sodium, if you look at the atomic number, it is 11. Okay, and the configuration is 281. Electronic configuration is 281. Chlorine, the configuration, the number is, total number is 17. Atomic number, configuration is 287. Now, if you look at their electronic configuration are not stable. Stable configuration means the octet. Okay, so they want to be stable. They want to get the octet configuration. So sodium, if you look at sodium, outermost electron, there are 1. In order to have 8 electrons in the outermost orbit, it can either lose 1 electron, okay, or it can add 7 electrons. Which is easier? Losing 1 electron. So sodium loses 1 electron to give you Na plus. Okay, if you look at the electronic configuration of Na plus, it will be 28. Have a look, outermost valence is octet. Similarly, chlorine. Outermost electron is 7. It wants to be stable, have octet configuration. How can it achieve octet? Either by losing all 7 electrons or by gaining 1 more. 7 plus 1, 8. Which is easier for chlorine? Gaining 1 electron. So chlorine gains 1 electron to give you Cl minus, and you'll get the configuration 288. Sodium loses 1 electron to form Na plus. The 1 electron that sodium loses, it will be given to chlorine. to form Cl minus. Now have a look, both of them will have very stable configuration. Okay, so they form Na plus and Cl minus, a cation and a anion. So there will be, of course, force of attraction between the positive charge and the negative charge. Yes, and they stay together and form the ionic compound NaCl. Okay, and the force of attraction between these charges, positive and negative, here is called electrostatic force of attraction. Okay, you need to remember the name, electrostatic force of attraction. Okay, there will be electrostatic force of attraction between the positive ions and the negative ions. Yes, so this is how NaCl is formed. And this ionic bonding concept was proposed by the scientist Kossel. Okay, Kossel, K-O-S-S-E-L, Kossel. Okay, he's told that when some atom loses electron, it will form stable cation and the other will form stable anion. Okay, then they form a compound having an ionic bond. The force of attraction is electrostatic force of attraction. Now let's try to write this formation of NaCl by electron dot structure. Okay, how do we do? Na, yes, it has got 2, 8, 1 electron. So its electron dot structure would be Na dot. Yes, 1 electron in the valence shell. Chlorine is your 2, 8, 7. Valence shell 7. So 7 dots or crosses also we can use. I'll use cross. 1, 2, 3, 4, 5, 6 and 7. Okay. In order to have a very stable configuration of octet, this 1 electron, it will be given to chlorine. I've made with an arrow. Okay, so we'll get Na plus. Yes, then chlorine. Now 1, 2, 3, 4, 5, 6, 7 of its own. 1 from sodium, and it will get a negative charge. Yes, if you write the configuration of Na plus, it will be 2, 8. Okay, and for this one it is 2, 8, 8. Okay, electrostatic force of attraction between them, they form NaCl. Okay, so this is how you write. Then let's see the properties of ionic compounds. Okay, the compounds formed by the ionic bond, they are called ionic compounds. They will have certain set of properties. Let's see the first one, very important. They have strong electrostatic force of attraction between ions. First thing you need to remember about ionic compounds are they are made up of ions, positive and negative, and the force between them is strong. Okay, very strong, and name is electrostatic force of attraction. Okay, and the other properties can be explained by this very first property. Number 2, they are generally solid in nature and are very hard and brittle. They are generally solid and very hard. Why? The reason is point number 1, because they have got very strong electrostatic force of attraction between ions. Okay, next, ionic compound have high melting and boiling point. Okay, their melting point and boiling point is very high. The reason why? Again, point number 1. They have got very strong electrostatic force of attraction between ions. That is why the melting point and the boiling point will be higher. It will require more energy to melt and to boil them. Then next, in molten state means the liquid state. Okay, or in solution, ionic compounds conduct electricity. Okay, they can conduct electricity. They can let electricity flow through them. Okay, pass through them. In which state? Molten state. In liquid state or in solution. In solution means mixed with water or other solution. Okay, water solution is called aqueous solution. They can conduct electricity because of the presence of free mobile ions. Okay, free mobile means movable ions. They can move. Ions are positive or negative charged species. For the conduction of electricity, charged species like ions are required. Okay, so in liquid state and molten state, liquid state and in solution, their ions are free and they can move. So they conduct electricity. Another thing to remember is, but in the solid state, okay, the ionic compounds do not conduct electricity. The reason, again, very strong electrostatic force of attraction. That is why these ions in the solid crystals, okay, they are fixed in their places. Okay, they cannot move. Okay, they cannot be mobile. That is why in solid state they cannot conduct electricity. Then the fifth one, ionic compounds are generally soluble in polar solvents. Polar solvents are the solvents which will have charge distribution in their molecules. Okay, like for example water. Water is H2O. It is also a polar solvent or compound. Okay, it's polar solvent. Polar solvent, why? Water will be like this structure. Okay, it will have minus charge, del minus a small negative charge, and del plus a small positive charge. Okay, so oxygen will have negative. There will be charge distribution like this in water. Okay, that is why it is called polar. Two poles, negative and positive, polar. Okay, and even ionic compounds, they have charges like this, plus and minus. So ionic compounds can dissolve in polar solvent having charges like this. Okay, so like for example NaCl. Okay, NaCl, common salt, can dissolve in water. Yes or no? If you mix common salt in water, it dissolves. Why? Because this is a polar solvent. What happens is Na plus and Cl minus will be there. Yes. Now this is also charged. Yes. So the negative part of water will try to attract the positive and surround it. The negative part of Cl or NaCl will be attracted by the positive part of water. Okay, so if you put it in water, what happens is Na will be surrounded by water molecules like this, minus charge. Okay, have a look. Minus charge will surround them like this. Okay, and chlorine, minus will be surrounded by water molecules like this, positive ones. Yes. Positive, positive, H, positive. Okay, so they will be surrounded by water molecules like this. Okay, so they get separated and dissolves in water. Okay, but they do not dissolve in non-polar solvents. Non-polar solvents do not have charge distributions like this. Okay, they do not have charge distribution. In other words, you can say like dissolves like. Okay, like dissolves like, meaning positive, they have got charges, these also have charges. Yes, so like compounds dissolve like compounds. And the names of the non-polar solvents are carbon tetrachloride, CCl4, carbon disulfide, CS2, benzene, C6H6. Now let's see the formation of more ionic compounds. The first one is lithium hydride. Okay, let's try to write the formation by using the electron dot structure. Okay, lithium hydride, the first one, lithium hydride, is LiH. Yes, lithium, you know, the atomic number is 3. Okay, its configuration is 2, 1. Okay, and hydrogen, the atomic number is 1, so electronic configuration is 1. Okay, now if you want to draw the electron dot structure, lithium will have 1 electron. So I'll just write 1 electron in the outermost orbit means 1 cross. Okay, hydrogen 1 dot. Yes. Now what happens? This lithium will, its metal will have the capacity to lose electron and form the duplet 2. Okay, so it gives 1 electron to this one. So we'll get Li plus, loses 1 electron. Hydrogen already had 1 electron. 1 more is added. 2 electrons, duplet. Okay, you saw that for the noble gases helium, duplet is also stable. Okay, so here L plus H minus, so it forms LiH. Okay, then another one is calcium oxide. Okay, calcium oxide. Number 2 is calcium oxide. Calcium oxide is CaO. Okay, calcium, you know the atomic number is 18. So sorry, 18, what am I writing? Atomic number is 20. So the configuration is 2, 8, 8, 2. Okay, 8, 9, 10, 8, 9, 10, 20. Then oxygen will have, the atomic number is 8, so 2, 6 configuration. Yes, it will try to lose 2 electrons, it will try to gain 2 electrons. So if I draw calcium, the electron dot structure would be how many? 2 electrons out. So 2 dots. Can I draw like this? Yes. Oxygen 6. 1, 2, 3, 4, 5, 6. Yes. It will give 2 electrons. So let's put with the arrows. So we'll get Ca plus. How many plus? 2 plus. Okay, don't just write 1 plus. Ca 2 plus. Then oxygen, it had 1, 2, 3, 4, 5, 6 of its own. 2 more from calcium. It will be 2 minus. Yes. So 2 plus, 2 minus, there will be attraction. So it forms CaO. Yes. And if you look at here, see, Ca2 plus 288, 28. Very stable configuration. Okay. So they form the ionic compound CaO. Okay. Now let's talk about the next one, magnesium chloride. MgCl2. Okay, magnesium, okay, configuration is 282. Atomic number is 12. 282. Then chlorine out here is 287. By now you know chlorine is 17287. Okay, let's write magnesium 2. Okay, 1, 2 I'll draw. Then 1, 2, 3, 4, 5, 6, 7. Okay, so magnesium will try to lose 2 electrons and chlorine out here will try to gain 1 electron only. Okay, so 2 electrons, it can't give both of its electron to just one chlorine. Okay, it needs to lose 1 more electron. Okay, 2 electrons. So it requires how many chlorine atoms? 2. Okay, so what we do is Mg. Okay, 1 and 2 I'll write out here. Then 1 chlorine atom, 1 chlorine atom. 2 chlorine atoms. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6 and 7. Okay, so goes here, another goes, transfer happens here. Okay, so when this is transferred, you get Mg2 plus. Okay, out here chlorine 1, 2, 3, 4, 5, 6 of its own, 7 of its own. Then from magnesium, so minus charge. Here also Cl 1, 2, 3, 4, 5, 6, 7. Then from magnesium minus. Okay, to chlorine we can write like this, Mg2 plus. Then how many chlorine? 2 Cl 1, 2, 3, 4, 5, 6, 7, 8. Can we write like this? Yes. 2 plus, and how many minus are there? 2 minus. Yes, balanced. Then there will be force of attraction. It will form MgCl2. That force of attraction is called electrostatic force of attraction. That is how it's formed. Similarly, by now you know how to do it. Sodium fluoride. Sodium 281 loses 1 electron to fluorine. 287. Then it forms Na plus and fluorine minus. Yes, they will have stable configuration. And for NaF, sodium fluoride. So this is how you make the formation of ionic compounds, how you write by the electron dot structure. Okay, and these are quite important. You need to practice a lot. Okay, you need to know their atomic number. Okay, and yes, the electronic configuration. Okay, how to write the electronic configuration. You have done it in the previous chapter also, no? Periodic table, and in the lower classes also you have done. Let's see the arrangement of positive and negative ions in solid state for ionic compounds. Ionic compounds, they consist of ions, and there will be a strong electrostatic force of attraction between the ions. So they form hard crystalline solids. Okay. For NaCl, this is the figure in the solid state. Na is the blue one, okay, and Cl minus are the orange ones. As you can see in the solid state, there will be arranged in a very ordered manner. Can you see the ordered arrangement? Yes. And if I take Na plus, okay, a charged particle, it is circular in, it's round in shape, okay, and it can be attracted by a negative ion Cl minus, okay, and this attraction is not in just one direction, okay. The Cl minus present out here can be attracted by Na plus, Cl minus present out here, here, in all directions, okay. So this is non-directional in nature. So here in a compound, okay, let's take NaCl, there will be many Na plus and many Cl, yes. So one Na can be attracted by many Cl minus ions. For example, here for NaCl, one Na will be surrounded by 6 Cl minus, and one Cl in turn will be surrounded by 6 Na plus. Here, have a look. Suppose let's take this Na plus, okay. At the back there is 1 Cl, at the front there is 1, 2, up and down 3 and 4, sideways left and right 5 and 6 Cl. Okay, suppose you take this Cl. Let's count the number of sodium ions. Front and back 1 and 2, up and down 3 and 4, left, okay, right, it is not given out here, but there will be extension of this cubic structure here also, yes or no? So there will be here and this side as well. So 6. 1 Na plus surrounded by 6 Cl minus, 1 Cl minus surrounded by 6 Na plus. Okay, it will be like that. And if you look here, okay, 1 Na surrounded by 6. If you join these Cl's, okay, you will see that this geometry is octahedral. Octahedral meaning having 8 faces. Okay, having 8 faces. So the geometry is octahedral. Now, different ionic compounds will have different geometry. Out here this is octahedral shape, others will have tetrahedral and so on. How do we see which ionic compound has which geometry? By the ratio of their ions, okay, radius of their ions, by the ratio of the radius of their ions, okay, R plus divided by R minus. R plus is the ratio of the cation, R minus is the ratio of the anion. Okay, so if it falls between this 0.414 and 0.732, this will be an octahedral. For NaCl, it is octahedral. Okay, then another thing, ionic compounds, there is no existence of individual molecule, meaning Na plus and this Cl minus will form one molecule. You can't say that, okay, because Na plus are surrounded by so many Cl minus. You can pinpoint there is this molecule, this is one molecule, this is another molecule and all. Okay, so there is no existence of individual molecule. It can exist as a giant molecule. That is why the term molecular weight is not used for ionic compounds. Instead, we use the term formula weight. Again, formula weight of NaCl is given this one. In solid state, ionic compounds do not conduct electricity. This one we discussed earlier. Ionic compounds can conduct electricity only in the liquid state, that is the molten state, or in the aqueous solution, but they do not conduct electricity in solid state because of the absence of free movable or mobile ions. Next, the limitation of octet rule. We saw that for the formation of electrovalent compounds or ionic compounds, one atom it loses electron and the other atom it gains electron. Okay, for the formation of the very stable configuration, that is 8 electron in the outermost orbit, which is called octet. But this octet rule is not applicable in all cases. Like for example, there are certain exceptions like this lithium hydride, LiH. You saw earlier, lithium loses 1 electron to hydrogen to form LiH. And as you can see, both of them will have duplet structure, 2 electrons in the outermost orbit. Duplet arrangement. Yes, so this is an exception. Another exception would be FeCl2, FeSO4, NiSO4 and all. Okay, the metals out here are all transition metals. Transition metals you did in the periodic table chapter. Here, this one. Okay, this middle portion out here, these are the transition metals. So they do not follow this octet rule. As you can see, iron is here, nickel is here. Okay, these exceptions you need to remember. Now let's see what are the things we left over here. Discovery of noble gases. Okay, let's do a little bit about this. Noble gases, you know, they are inert gases that do not like to react with other elements. Yes, and you know that inert gases, all the inert gases are present in the atmosphere in very small amount. Okay, 1% by volume. Only this is absent. Radon, which is radioactive. Okay, and Lord Rayleigh was the first one to discover the noble gases. Okay, the first gas discovered was argon in the year 1894. Okay, Lord Rayleigh discovered it along with Ramsay. Ramsay was also his apprentice. Okay, now let's see how he discovered noble gas argon. Actually, he was studying nitrogen gas. Okay, and he collected nitrogen from air. Air also has nitrogen, you know that, yes or no? And he collected nitrogen from air and he calculated its density. It was found out to be this much. Okay, again he took nitrogen from another source, that is by heating ammonium nitrite. Okay, ammonium nitrite is NH4NO2. Ammonium nitrite. When it is heated, it will give you nitrogen, and the other one, it gives you water. See, nitrogen is there, pure nitrogen. So this nitrogen from ammonium nitrite, the density was 1.24, which is less than the previous one. Yes, so he concluded, okay, one same atom, same like gas cannot have two densities. Yes or no? Something must be wrong. So he concluded that there must be some other gas in the air that he collected. Yes or no? In the nitrogen that he collected. And later on, by studying more, he found out this argon, okay, the gas argon was there, which was chemically inert. Okay, the first noble gas. Then later, other noble gases were discovered, and Ramsay, okay, Ramsay was very much interested after discovering argon. Ramsay was very much interested in the noble gases. So he studied noble gases, okay, and he thought that there might be other noble gases other than argon. So far, he discovered helium, okay, krypton, xenon, then later neon also he discovered. Okay, all these from the air. What he did was, the air was liquefied. Okay, it was cooled and liquefied. That was called here liquid air. And this liquid air was subjected to fractional distillation. Fractional distillation, you have learned this term. Yes or no? The separation method. Yeah, the substance is heated. Okay, and the components can be separated. Okay, so all of these noble gases will be present in the air. Of course, we can separate from the liquid air, no? All of these gases. So Ramsay and Travers discovered these noble gases later. And Lord Rayleigh and Sir William Ramsay, they were awarded Nobel Prizes for the discovery of noble gases in 1904.